Hello, this is Mr. Weideman, and this is Pre-Calculus, Lafayette High School. This is section 4.6 on using logarithm and exponents to solve for x. Okay, this is one of our first example problems. Your hint here is log base 3 in each term. So this is probably going to be a relatively straightforward problem. Okay, this term I'm going to do nothing with, but you should recognize that log base 3 to the 9 is just simply 2. And I moved the 2 over to the other side of the equation. Okay, now at this conjuncture, I am going to convert it to an exponential. You can use your little rat tail, that's fine. Or you can raise each side to the exponent using base 3, and we can use our inverse property. Okay, that's really what's going on. If you just want to use your rat tail, that's fine. Okay, and at this point right here, we have a quadratic to solve. Okay, and rather than FOIL it out and solve, which would work, I can just take the square root of both sides, and a little bit easier than FOILing it out and factoring, although that will work. And so I have two answers, which I always do in a quadratic. Now, why did I cross out the negative 13? Remember, a logarithmic term cannot be negative. So if I take negative 13 plus 4 in this logarithmic term here, I'm going to get negative 9, and that can't happen. So I have to throw that answer out. Make sure you go and back check your answers. Sometimes they both make sense. Oftentimes you have to throw one of them out. Okay, let's go to the next problem. Okay, what's going on here? Major ugliness. Okay, the bases are hideous. But what I'm going to do, how do I get at variables in the exponent? The answer is, I kind of start out the same way. I am going to take the log of both sides, and when I take the log of both sides, I'm able to use the power rule. And I kind of skip that step a little bit, but imagine, okay, this guy here, what did he used to be? He used to be an exponent. Same with this guy right here. He used to be an exponent. That's why we take the log of both sides. So those exponents are now coefficients. All right, now here's where it starts getting ugly. Log 0.3 is merely a number. It's an ugly number, but it is just a number. So what happens when I see a number outside of parentheses? I can distribute. And that's exactly what I did. All I did is on this side, I distributed the log 0.3 term, okay, here and here. And on this side, I distributed the log 1.7. All right, there it is times 1. There it is times 2x. Okay, so I distribute. Now remember, this whole gobbledygook right here, it's a coefficient of x. It's an ugly one, but a coefficient of x. All right, and my next move is I'm going to combine like terms. Okay, I'm going to get all my things with the x variables on the left side, all the other things on the right side. Do my grouping. Okay. Remember, this is commutative. If you wrote log 1.7 times 2, that's fine. Just do not confuse it with log 1.7 times 2. That's wrong. Okay. And then I'm going to factor out the x. Leave the right side alone. Okay, now I'm ready to divide to isolate my x. Now, if you want to, you can put all this mess into your calculator. And that's fine. You're going to have to do it eventually. But if they want it left as exact, then you have to do all that. Now, that is just merely a number. Let's say it was x times 5. What would I do? Divide both equations by the 5. Now, here it's x times ugly mess. What do I do? Divide by ugly mess to isolate the x. And that's exactly what we do. And that will give me your final answer in exact form. Punch that out in your calculator. Use lots of parentheses, right, to force correct order of operations. And that should be your answer. Okay? All right. Last problem is a bear. Okay, this guy right here, here's the mess. Now, you're going to need to know this to solve for problem number 37. This gets kind of intense. So let's follow each step around closely. Now, we notice that when we problem solve, if the bases are all the same, they're not so bad. So what we're going to do is we're going to use our change of base formula. In the log base 4x, I'm going to change to a log based 2x. And that's my change of base formula. All right, now what does that buy for me? Well, if I look at that denominator term, log base 2 to the 4 is simply 2. All right? So, now what I'm going to do is I've got that 2 in the denominator. Remember, that came from this guy. Log base 2 to the 4 evaluated is just simply 2. All right, I'm going to clear the denominator. I'm going to clear the fraction. That just means I'm going to multiply through by 2, just simply to get rid of that denominator. Okay, now if you see here, everything's all kind of nice. Everything is log base 2. Now let's use our condensing rules. Let's use the power rule here. And then our next step is we can use our quotient rule. All right. Now we're going to convert this from a logarithmic to an exponential. Use your rat tail if you want to. It's all the same to me. Okay, now the rest is algebra. I'm going to multiply both sides by x, and then I'm going to FOIL, and then I'm going to do a lot of other garbage. Okay, but there's my first move. 2 to the 6th power is 64. I multiplied both sides by x. Okay, what has to happen now is I make the quadratic equal to 0. If I'm not mistaken, this does not factor, so I have to use the quadratic formula. And then there's my 2 answers. I think number 37, it actually factors nice. But here, it doesn't factor. Use the quadratic formula, and we got our 2 answers. Actually, if I was a good student, I would go back and I would get like just a decimal number for this guy, this mess right here. And we really should substitute it back into here or here and see if anything is negative. Something tells me one of these answers is probably negative, like the 52 minus the square root 2560. 52 minus square root 2560. Oh, it's positive. Okay, so I think they're both going to work. All right, never mind. All right, good luck with your homework.